Okay, now let's welcome on stage Lee and Hewraz. They will be talking about managing the resource manager.
Thank you, Anna. Hi, everyone. My name is Hewraz, and I am here together with Lee today. We are both software engineers working at Cisco with NSO support, and today we're going to talk about how to manage the resource manager. Right, so we have like 30 minutes to go through as much as possible about the resource manager. It might be a bit fast-paced, but since we are so short of time, I thought I might waste some of it by asking everyone, how many in here are using the resource manager? Hands up. Okay, that's like four or five out of a lot more. Okay, interesting. So the agenda for today is going to be that we're going to start by talking a little bit about the resource manager, what it is, how it works, and what it does. Then we're going to move on and talk about or showing two examples of how to use the resource manager with the synchronous and the asynchronous API. And then we're going to finish up by talking about how to troubleshoot the resource manager. The resource manager is a package created and supported by us at Cisco. It is, like the name says, helping you to manage your resources. And a resource in this case would be an IP or an ID, which is an integer. So the way it works is that you just load a package into your NSO, and then you can start creating pools and allocating your resources out of those pools. And it is all on NSO, so you don't need any external systems or anything like that to be able to do this, if you don't want to. The package is intended to be used by services, so it comes with service APIs for Python and Java. It allows for synchronous and asynchronous allocations. We're going to go through the details of those a little bit later in the presentation. It allows for synchronizing pools, so if you make an allocation in one pool and you want to synchronize that, then that allocation can be synchronized and added to other pools as well. It allows for static allocation, so you can tell the resource manager that I want to allocate this specific resource, and it will do this for you. And it also allows for multi-service allocation, so multiple services can allocate and thus share the same resource. The resource manager is based more or less on a Java subscriber, a subscriber implemented in Java. It monitors a certain part of the CDB where you can configure your resource manager stuff. And this subscriber will react on that and do the allocations for you. Or at least that's how it works with the asynchronous allocation. Now, lately, when we have added support for synchronous allocation, this subscriber is not used for that. But however, the logic is reused and shared. So it is more or less using the same logic, but it's not going through the subscriber. So you start off when you use the resource manager by creating pools in the CDB. That's just configuration. You create a pool, you give it an ID, and you give it a range of resources. And then you can start allocating your resources from that pool. And that is by adding config to the CDB if you are doing it asynchronously. Or if you do it in the sync mode, you do that by invoking an action that eventually will add the config to the CDB, but it is going through an action. And that is also all supported by the service APIs that comes with the resource manager. And if you use the asynchronous mode, then once the allocation is done by the subscriber, then the subscriber will redeploy your service for you. So your service can read whatever it allocated. If you want to create or make an allocation, what the resource manager will do is basically just pick the first available resource for you, save it to the operational data, and then telling you that it's done now. You can take it and read it. If you want to delete an allocation, you have to delete the whole allocation request. For instance, and it's also worth noting that if you use the static allocation and you provide an ID or an IP, a resource, to the resource manager, telling it, okay, I want you to allocate this resource for me, then it does it. And then you just remove that line of config or input parameter where this specific static ID is that you provided. If you just remove that ID, the allocation will still remain. It will not be deleted. And this is a useful thing if you are running the resource manager with the brownfield and service discovery scenarios. So like I said, in order to completely remove the allocation, you have to delete the whole allocation request. But if you use this with the API and your services, then FastMap will do that for you. So you don't have to worry about that. And it is also possible to modify the pools or resize them. So you can increase and decrease the pool size. What this will do is that it will redeploy every single service that made an allocation on the resource or on this pool. That can be a bit costly. So it is not really super recommended to do so. Hopefully, there's no need for doing so. Your pools will be static. But if you do so, then it works, but it will redeploy a bunch of services. And with that, I will hand it over to Lee.
Thank you, Hewraz, for showing us the overview of Resource Manager. And now let's take a look at some kind of recommend design alternative. We will focus on code review. We have two demos, of course, with the code. First, with asynchronous allocations, it's not really complete synchronous. It will be synchronous with ID first, which is VLAN ID. Then with the ID we allocated, we use it to allocate IP, which is asynchronous mode. Then we'll have full asynchronous allocations. This one will, the first one will be with FastMap. Second one will be with Nano service. We will show with Nano service things are much smoother. By saying so, let's start look at the first one, synchronous allocations. So we'll show the demo after this slide. This is a general overview. We'll start allocating ID first in synchronous mode. Then we use the ID as device config. It's more like a VLAN ID here. With the ID we allocated, we use to create IP pool. So consider you have IP address 192.168.x.something. The X will be the ID we just allocated there. Generate to get your IP from a DHCP or IPAM and so on. And of course, when you reach this stage, you will be failed. You will say the pool is not found, of course, because you just configured it. It's still in transaction. It's not going to be seen here, which will trigger redeploy. Everything will go through again, but until here again, it will pass, because now I can find the IP pool. And with the IP pool I found, I managed to locate the IP, which eventually I can use the IP as a device config again. The general overview of what's happened internally, as diagram here, when you have asynchronous locating the IP here, you actually go through a Java CDB subscriber, like Hewraz mentioned before. This CDB subscriber interact with Java allocation core, which is the one that actually locating ID and IP. This you can consider as like IPAM. Previously, you have IPAM externally, but now we have IPAM inside NSO now. And if you have synchronous mode, you don't need the CDB subscriber anymore. You just directly interact with the allocation core, which means this will be blocking. This one, you can allocate it, do something else, keep checking if it's ready. Once ready, you get ID, you proceed forward. By saying so, let's take a look at the demo. I hope this one can show. One second, I just need to move the mouse to play button. Yes. So first of all, you can see we actually send all the ID allocation requests in one place, in one single for loop. Then we get all the ID allocated in a second for loop. The reason of doing this is actually because if you don't send it in the entire for loop there, you will, if something failed, you will miss the rest of the service evaluations. And but if you put it in one loop, what you have is, even if it failed, all the requests on CDB already, CDB get it, you still can proceed the rest of it. You won't see a bunch of configuration getting deleted. And then we use actually this one too fast. Let's see if we can go back a little bit. We actually use the ID we allocated here. We use it to create device config we mentioned there. Also to create IP pool. And you can see this digit is the one that we use the VLAN ID we allocated previously. Which at here you will see redeploy. After they come back, we'll pass, we get IP address, use the IP address for device config. We do put the ID pool creation in the pre-modifications because we want to show if when you have ID pool creation in the first place, it's better to do outside the fast map, not inside the fast map. But it's better to not do it pre-modification actually, just doing CLI. And here we start running the code, building the NSO, and also start the netsim. When this is done, we will actually start with calling the code with synchronous allocation ID, but synchronous on ID, asynchronous on IP, which you will see different here, means the asynchronous allocation is a side effect. You won't see in the commit dry run. But synchronous allocation, you can see in dry run. It's not a side effect. So in here, I put the config I put on my YARN model. I will start with the commit dry run. You will be able to see a bit upwards. Let's see. You see the ID is here in the device config, but you don't see the IP. Because the IP is asynchronous. It's a side effect. But even you don't see it here, when we commit it, you still be able to see it actually putting it in. And all those things you see here is IP and ID allocation request, which is the one we mentioned before. So now I actually commit it. If I actually look at what's on the device here, you can see the IP and ID, even though we don't see the commit dry run up there. Yeah, and by saying so, I'm not going to show the asynchronous one, but because asynchronous Hewraz has a better demo, I believe, which is the NANO service. Why don't you take over?
Yes, thank you, Lee. Thank you. Right, so for the asynchronous API, I have written an example using nano services, or a nano service. I know what you say now, like, oh, no, I don't want to use nano services, oh, it's too complicated. But I'm here to tell you that, no, it is not complicated. And I'm going to keep coming back every year to tell you, no, nano services are not complicated. So here's an example. This nano service does 3 important things. It is going to allocate an ID, which would be an integer. It's going to use that ID to create an IP pool and allocate an IP from that pool. So that's the next step there. And then eventually it's going to configure the device with the resources it allocated. So I've made 3 plan states with callbacks for these steps, basically. And let's go through these steps. So here there are 2 important things to look at. I have imported the API, the Python API from the resource manager into this code. And the 2 things that I'm using are this ID request function. I don't know if you guys see over there or if I'm standing in a way. This ID request function and this ID read function. So the first thing this callback is going to do is that it is going to request an allocation for the ID. And it does so by calling this function, and this function will configure the CDB to trigger the subscriber. But the subscriber will not react to this modification until the transaction is applied and the changes are on the CDB. So the first time this service actually redeploys and we make this function call, the changes will be in the transaction, not on the CDB. So we will get to the next step here, the ID read one. This here will read the right part of the CDB where the allocation result is supposed to be. But during the first redeploy, nothing will be there because the allocation has not been triggered yet. So we verify whether or not the allocation is ready by looking if we have received something. No, we didn't. So we set the status to not reached, and we return. And once we return this callback, we allow the transaction to continue and be applied, make the changes into the CDB. Then the resource manager subscriber will react to this, make the allocation, and redeploy this service. Once it redeploys this service and the allocation is ready, we will go through all of this again. So we will do this call. This will be a no diff on the CDB because the changes are already there. And then we will go here. And now we have the ID ready for us to grab. So this check returns false. And we can continue here. And we continue by saving the ID into the prop list so we can use it in the next callback. And that, ladies and gentlemen, is reactive fast map. So anyway, in the next step, here we take the ID that we allocated in the previous step, and we use that to create our IP pool. And that is just config on the CDB. So we've created our template, and we just configured the pool with an ID, pool ID, and a range of IP addresses. And as you can see, the range is actually based on the ID that I allocated in the previous callback. And then we do the same thing here again. We request the allocation. It's not going to be ready. We try to read it. We don't get anything back. We set the status to not reached. We return. And then we let the resource manager do its thing. Redeploy the service again. We go through the whole thing again. And then we get an IP allocated. So we take that IP. We save it into the prop list so that we can use it in the next state. And this is the next state. Configure devices. Configure device. So here we just grab the ID and the IP that we saved in the prop list. We apply it to our template, and we eventually going to configure our device with it. So this is what it looks like in CLI. First, on the top left corner, we have a pre-configured VLAN pool, or we call it VLAN pool. It's an ID pool. It has a range of IDs. And we pre-configure it because we do not expect it to change. It is not going to be dynamic in any way, so we pre-configure it compared to the IP pool that is dynamic based on the allocation we did from the ID pool. So that is pre-configured. Then we create our service up here. That's just to illustrate that we create the service. Don't need to pay attention to the config. And then we commit it. And if we do a commit dry run, this is what we're going to see. We're only going to see the config of the ID request because that is as far as it gets, like I showed you before. Then it's going to return and wait for the allocation. So this is the only thing we'll get in a dry run. And then it's going to do this whole, reactive redeploy, reactive fast map thingy. And eventually, when it's done, the plan is going to look like this. Everything's ready. And just to verify what every state did, the first one, as in the dry run, only configured the ID request, right? Yes. And then the next state is going to create the pool. We can see that in the bottom here. Create the pool, give it a range, and also added a request to it. So that's the config diff we're going to see for that state. And then on the final state, we see the device actually being configured with the resources that were allocated. So let's compare these two modes of using the resource manager. What's the difference? Well, one is synchronous, the other is asynchronous. What does that mean for your services? Well, I think that the synchronous API is simpler to understand. You have this sort of request response model, so you know that once your function returns, the allocation is ready. So you don't need to do this whole redeploy, keep checking, is my allocation ready or not, redeploy. It happens, synchronously. And the benefit you also get from this is that you can use dry runs. So now your service can finish the whole thing with only one redeploy. So you will be able to see the end result of the service in your dry run, compared to what I showed you before, that our dry run only showed the first allocation request. However, since it's synchronous, it's blocking, so it's going to block your service. But this is not that big of a problem if you use NSO 6 and above, because your services are going to run in parallel. So still worth knowing, though. So asynchronous, obviously, is not going to block your services. But you have to rely on redeploys, and you have to rely on reactive fast map and a bunch of redeploys, and keep checking whether or not the allocation is ready. And as far as I've heard, everyone are afraid of reactive fast map, so maybe that's a downside. I don't know. But it's up to you which one you want to use. And with that, I will hand it over to Lee.
So now, everyone has an overview of how Resource Manager work, and we see the recommended best practice by putting together service code. What happened if something went wrong, right? I guess that's most of the time when things happen. You expect it to work as perfectly, but something went wrong. So we have some tools. So first of all is logging. So I think when everyone who uses Resource Manager, you will realize the logging is quite brief. Because you have, if to enable the detailed logging, you have to set the Java VM level to debug. By setting so, in Java VM log, you will see more detailed logging, which show you what exactly the subscriber is doing in asynchronous mode. In synchronous mode, it will also show by direct interact with the allocator what is happening. It's separated to 4 sections, marked with 4 colors. You will first have the time, purple one. Then you actually see which module is calling what function. For example, is here, ID allocator is doing iterations. To make it more readable, we actually have a human readable description here. What is actually doing? Reactive fast map ID allocations. And afterwards, the green part shows the internal logging. What's the current state? Where is it running the code? Same as this one. You can see synchronous allocation. We got ID, VLAN ID, actually in this case, 31. So if something went wrong, you actually have a way to see what exactly happened. Which means if you actually open case towards us, this is actually how we troubleshoot it. And what happens if I want to fix something? We also have a developer toolset. As the name is called, is developer toolset. Don't use in production, please. Difference here is you call it as level info. When you call it as level info, you will get access to the toolset. All the toolset is actually an action here. One thing, not only the info, you also need to unhide it. Because if you don't unhide it, you don't get access to the action callback here. And the tool you can call have 3 categories: reporting, fix, and forcing. Reporting will give you a report. For example, what ID and IP you have currently allocated in the pool. And also try to check if anything has been missed, generate a report for you. Those are not going to fix anything. It's just going to give you the report. If you're trying to use some kind of automatic fix, we have a fix toolset. If you know something wrong with allocation ID, something's missing, you can try to call fix missing allocation ID. Owner missing, fix missing owner. It's basically by what his name is doing. Give it a try. If it fixes your problem, of course, that's good. Otherwise, well, we step in. If something is not synchronized towards each other, for example, your pool and something else is unsynced, feel free to use persist all. Force it to be persistent. By saying so, that concludes our presentations. Any questions? We also have Sandeep here from Resource Manager BU, our tech lead, to answer more questions, I think.
Thanks. If we use the synchronous mode with the Resource Manager, right, the dry run will actually show you an ID allocated, let's say. Now, what if you decide not to commit? For how long? Because it seems to be that after you commit, right, the actual ID you get, the one in the dry run you get in the commit. So it's somehow persisting in the background to a certain degree. Is it like a timeout or let me put it differently. Let's say a typical situation. An engineer does a dry run, goes on a lunch break, comes back, does a commit. Would they still the same ID be there, or?
I mean, before you actually commit, it's not going to enter your CDB, right?
Mm-hmm.
So it's just going to, you call something, it gives back an ID to you. It's not actually allocated yet.
I understand.
just give you this ID. When you actually commit it, you have the ID in the older CDB as the one you allocated, then you put it actually inside CDB. So dry run will be fine.
Okay. No, what I'm trying to say is somebody in parallel maybe, not necessarily, let's say 5.8 NSO. No, it's not concurrent yet, right? Let's say somebody in parallel beats the original guy to the commit. Could it happen that, the ID might be, let's say, so to speak, stolen from the standpoint of
So you like
driver?
parallel
Not necessarily parallel, running of the instances. It's just like the guy did a dry run, saw the ID, thought he's going to get the ID after he commits, let's say, later on. But actually, the ID is gone because somebody else, by pure chance, got it.
So you mean something like a racing
Perhaps,
condition?
yeah. What I'm saying is that like a possibility, or for how long that kind of dry run gives an ID, and then before the commit actually, let's say, wouldn't get the ID? Is that even a possibility?
I think that's possible.
Yeah, it's possible. It's a race condition. Right? So in the dry run, when you execute it, at that point of time, your in memory the ID allocator is different. But some reason is other guy also doing at the same time. It might have taken that, right? So when your actual commit happened, that particular ID is not available, so you will get a next value. And in the logs, you will see everything. So dry run is not going to commit anything. It's just showing the state at that point what you will receive. That's it, and it is possible.
Any more questions?
Are there any plans to improve the resource manager to play more nicely with the nano services? Because in the example you show, I think it's a bit of a hack to changing the plan in the code and basically implementing the reactive fast map inside of a nano service.
I think at the moment we have a discussion about this, right? The nano service using resource asynchronous mode, there will be the recommendations. With fastmap, the general fastmap, you have to over again. But yet, to answer your question, yes, we have improvement ongoing. Actually, by end of this presentation, we already have a resource management improvement plan ongoing. And since we already set React Fastmap and Nano service that invented by this guy as a best practice, there will be more fitting together.
Thank you.
You will see more coming, right, Sandeep? Yeah. Any more questions? Okay.
All right, thank you.
Thank you.
Thank you.